Okay, so let me talk about this again. Acceleration, you guys have to remember one thing. Make sure you have all three of these down. And it is either a change in velocity, which velocity is speed in a direction. Okay, it could be so speeding up, slowing down, or changing direction. It's really important for you to understand that it could be one of those or all of them. Okay, so write that down, make sure you have it. And if you have questions, raise your hand and we can answer them. Okay. Okay, let's do the next one. If I can find where my mouse went. Oh, there it is. There it is. Okay, only the top bullet point. Okay. Because the rest of it just explains it exactly the way I say it. So in science, acceleration is an increase in speed, a decrease in speed, or you're just changing the direction that you're traveling. Okay. So I struggled with this in 6th grade when I learned this. And my science teacher had to really explain it to myself and everyone else, because I was like, you know what? Acceleration, yes, you're going faster. I get that. Changing direction, okay. But to slow down, that's deceleration, right? And well, in English language, it's deceleration. But in science, to accelerate is to change speed or change direction. So the change in speed means a positive integer, meaning you can go faster, a negative integer, which would be like slowing down on the brakes in a car, or turning left or right, or if you're in an aircraft, up, down, barrels, that type of stuff, okay? That's what that means. And it took me a little while to kind of process it and go, okay. So it's just changing of speed or direction. So if you're going, well, Mr. Weber, accelerating means going faster, I totally know what you mean. And I've been where you are. Open your mind and just know that it's change of speed. Positive or negative, doesn't matter. That is acceleration for science. Okay? Don't say it in an essay saying I accelerated to -5 miles per hour. Your English teacher might be confused. I would understand it, but they might not. All right, here we go. So we already know that you don't need to write these, okay? We already know that changing acceleration means speeding up, slowing down, or changing lanes, that type of stuff. That is a type of acceleration because you're changing direction. Okay, we have that down. We know that. Now, acceleration describes the rate at which velocity changes. Velocity is speed in a specific direction, right? Good. Write that down. The last bullet point on this one. Acceleration describes the rate at which velocity changes. Increase of speed, decrease of speed, or changing direction, or all of the above. Okay, so let's keep going. So write this one down. In order for acceleration to be determined for an object, you need to calculate its change in velocity per unit of time. So it could be seconds, minutes, hours, days, whatever it is, okay? You need to specify what the rate is. Remember, rate could be meters per second, miles per second, centimeters per second. It could be any one of those, okay? So we're gonna get into that. The next slide shows the formula and write it down. You need to write it down. All right, so there is your calculation. There's your formula. Acceleration, or also known as A, is equal to final velocity. We put that in an equation of F of V. So FV, subtract initial velocity, that's the starting velocity of IV, okay? Divided by time. So here we go. We measure it in meters per second squared. You don't need to write this, okay? I'm going to teach you how to do it. I'm going to show you how to calculate everything using these formulas. And guess what? We are done for notes. So with that being said, I'm going to shift it over, pause. Okay, here we go. So number one, we need to find acceleration, right? So the formula we're using is A equals F of V subtract I of V divided by time. Final velocity minus initial velocity divided by time. We do this piece first before we do the division. Does that make sense? Okay. So number one is A of V equals, let's read it. It's a roller coaster. Ooh, who likes roller coasters? Me too. I'm an adrenaline junkie. Totally love it. Okay. So at the top of the hill, you start going down the slope. That's the hill. Its speed is 4m/s. M/s is meters per second. Remember, that's called rate. 3 seconds later, at the bottom, its speed is 22 meters per second. What's the average acceleration? So let's break this down and plug them in. So the only thing we have to solve for is A, right? What would be final velocity? Is that top of the hill or bottom of the hill? Bottom. What's the number? 22. 22. What? Meters per second. Good. So it's 2m/s. You guys should be writing this. Write's fairly small, so you have enough room. Subtract. No, I do not. Now I do. Who needs it? All right. So 22 meters per second. Subtract. Oh, what's the initial velocity? That must be at the top of the hill. How fast was it going? 4. 4 meters per second. How long did it take from top to bottom? 3. Okay. So we have it set up. Can we solve? We can make another step to solve it, okay? So the next thing we do, we start doing the basic math. What's 22 subtract 4? 18, very good. 18 what? Meters per second. There we go. You guys are great. Over 3 seconds. All right, well, this is just a division problem, right? Told you guys this is going to be easy. What's 18 divided by 3? 6. 6 what? Yes, good. A equals 6 meters per second. Now, I am a stickler. I look for boxes or circles for answers. And then I look for your work. So make sure that you box it or circle it. Okay? Don't put stars next to it. It's not Hollywood. You're not like a magic mathematician yet. We'll get there. Okay? So this is number one. How hard was that? Not hard. Okay? Feel better now? Getting there? A little bit? All right. So let me change pens because number one, well, that's one color. I'm going to separate it with blue. No, I'm going to do blue next one. Red? Okay, I'll separate it with red. Yeah, that's enough. Okay. Now, next one. 3 parts. This one's a little bit trickier. You're figuring out for 3 different things. 2 math problems, 1 determination problem. You have to compare the 2 math and figure out which one has the higher acceleration or if the bicyclist has a higher acceleration than the car. So let me set this up. Try to move it so the camera can see it. All right, that'll be good. All right, 2. It's a quick question. Should we write this? Do you think we have to every time? If you know it, you don't have to. But if you're like not sure, then go ahead and write it. It's perfectly acceptable to do that. Nancy's back in. Okay. All right, so number 2. Great, we're going to do this. We're going to do bike, car, and this is bike. Okay, so for the bike, a bicyclist, okay, accelerates from 0 meters per second to 8 meters per second in 3 seconds. So do we have everything that we need to figure out acceleration? 0 to 8 in 3 seconds. Is that initial, final, and time? Yes. So write it down, write the formula down on setting it up. I'm going to write mine and then compare. Okay? I'm ready. Are you? Yes? Is yours look like mine? Yeah? Right there? You good, Brendan? Okay, cool. Yeah. All right, so what's 8 subtract 0? 8. What's 8 divided by 3? Uh-oh, calculators. Get a calculator out if you don't have it. Yes. I'll let you use your phones if you can be appropriate with it. Only have the calculator feature up. What's 8 divided by 3? Yep, good. So well, you can cut it shorter, 2.66. So that's a bicyclist acceleration rate, 2.66 meters per second. Let's do the car. So the car has an acceleration rate of 0 to 30 meters per second in 8 seconds. So 30 minus 0 is what? 30, okay? Yep, good job. Over 8 seconds. What's the acceleration rate of the car? What? 3.75, good job. Meters per second. Okay, problem asks, is the acceleration higher than that of the car, which accelerates at, and it gives a problem. So is the bicyclist acceleration rate higher or the car? Car. So do we say yes or no? We're asking about the bicycle. Is the bicyclist rate higher than the car? No. So we need to write no. The bike does not have a higher acceleration rate than the car. That's number 2. Okay, so I need everyone to let me know when you're good with number 2 in here and online. And I'm going to show you number 5 because I'm going to erase number 1. Make sure that everyone knows this is number 5. So number 5, woo! Ryan, what car is number 5 talking about? Ferrari, yeah, okay. Everyone wants a Ferrari, right? No? Oh, really? Oh, nice. I know it's asking for a ticket, right? Okay, so the Ferrari, we need to know what the final velocity is. So if you guys look, this has 3 different types of equations. Your acceleration, you need to find time, it's over here. If you need to find final acceleration, it's this. So I'm going to write it out. So F of V equals acceleration times time plus initial velocity. That's how you have to set that up. That's number 5. So number 5 says it accelerates at 50 meters per second per second. Okay, so it's F of V equals 50 m/s/s times 3 seconds plus 10 meters per second. So let's do this. What's 50 times 3? 150. 150. So we do F of V equals 150 m/s/s plus 10 m/s. What's 150 plus 10? 160. F of V equals 160 meters per second. That is the final velocity for number 5. So, how do you guys feel about this level of math? Not bad, right? Okay, so for your official homework, do 3 and 4. And then when you guys do your online independent learning tomorrow, do worksheet 3, or excuse me, worksheet 2, all 6 of them. Okay, and then when we come back into class on Thursday, we'll do the notes for the upcoming week for potential and kinetic energy. And then Friday, we're going to be doing the test version of this and correcting any mistakes for these 2 that we're doing today and tomorrow. Okay? So you get plenty of time. All right, so you guys understand that? Okay, I'm going to stop the recording and then we're just going to do a fun math problem. You guys are going to help me. Really big numbers. Yes, fun math problem for kinetic energy.